Hey everybody, this is Jeff here. We're going to do Module 4 today, um, where we're going to talk about conditionals primarily. We'll cover a couple other things as we kind of bounce around a little bit here. I don't have slides this time either. I think what I did last time was I put my commentary kind of in the code as we went, and then of course I'll provide the entire file of what we do as an attachment. Um, what you'll do is you'll probably see me deleting things and adding things and deleting things and so on, whereas in the past I've tried to keep everything. The programs are getting more and more complicated, that it's harder to have like the whole full trail of the code all at once. So you'll have that as an attachment, but my recommendation here is that you have your own development window set side by side, and you should pause the video and do the exercises I'm doing and try the code, and that's the best way to learn this stuff, I would say. So let's go ahead and get started. Conditionals, right? So let me ask a question, right? Is there a program out there that does not need to ever make a decision? Can you think of a program out there that does not ever need to make a decision? Um, yeah, there are. For example, a program that converts between units, i.e. degrees Celsius to degrees Fahrenheit. So you enter a number in degrees Celsius, the computer does the calculation and gives you the temperature in degrees Fahrenheit. Um, on That's just a calculation, right? It's useful. It's not as useful as it can be, right? Without some additional things. Any conversion of units or any mathematical calculation, calculating the average of all the scores in this class would be another example. Calculating how much of taxes to pay on a purchase, things like that, all can be done generally without conditionals or decisions. We run out of utility quickly, right? In order for the program to really be useful in a general sense, um, we have to be able to make some decisions. Um, the most common way we make a decision in code is called a conditional. And the conditional is the statement we use most commonly to make decisions. And so the word condition, if you look it up in the dictionary, basically says it's a criteria that isn't always the same, right? A number is positive, or the temperature is high, or the bus is late, or something like that. And so that's what the word condition means. So the word conditional is basically actioning that, right? And so in essence, the conditional is the conditional itself is the expression that will get evaluated to true or false. Then, if true, something happens. Okay, so think about, we do conditionals in our life all the time, right? If it's cold outside, then if it's true that it's cold outside, then I'll bring a coat, unless you're my kid, right? If it's raining outside, I'll bring an umbrella or a hat. If if I'm running late, then, I might drive instead of bike to work. Okay, so let's demonstrate what that means in basic sense here in C++. Okay, so this is our conditional statement, and this inside the parentheses is our condition itself, or our condition expression. C++ requires that that condition be inside parentheses, right? So you can't do that. If I try to run that, it says the parenthesis is expected. Some programming languages don't require it. I would say even when programming languages don't require it, it's a great convention. Okay, and so the parentheses basically say that everything inside those parentheses are going to get combined and evaluated to create a single true or false, right? So if I run this now, and I enter a value of 5, my program stops, nothing happens. If I run it again and I enter a value of 11, I get my print statement. If I'll do it one more time with a value of 10, nothing happens. Okay, so this expression right here says to evaluate the value of x to see if it is greater than 10. Okay, this is where we're using our angle, our angle symbol here as a classic greater than symbol that we've learned, back in math, right? And so if x is 9 or 10, this expression will evaluate to false. If it's 11 or 100 or 2000 or whatever, it'll evaluate to true. And if this expression evaluates to true, then the code that will get executed inside these curly braces that are associated with this if statement. Okay, the if statement is the conditional statement. The thing inside parentheses is the conditional expression that gets evaluated. And then the body of code that gets executed, if the condition is true, is inside the curly braces following the statement. Okay? So important to see here that that this line, in this case it's line 36. By the way, it may or may not be 30. I have a comment in the code that I'm going to say as I'll say this. So I'm going to just say, note that the line, the cout line will not execute all the time. And the problem here is that my code may not exactly match. I made some notes here on a screen here that is my secondary screen. So when you see that, right, so the line above cout inside the braces will not execute all the time, right? So until here, every line of code from top to bottom would execute once in order, right? And so now you're seeing a way of skipping over code based on if something's happening. That's called a branch. Okay, so now, some of the guts of the terminology is we are doing a conditional branch, and if the condition is false, we're doing a conditional branch from line 35 to line 38, basically. It's actually not line 38, it's whatever statement is next, because the line 38 doesn't exist once the program gets processed. But I think for the point that we're talking about here, is if this condition evaluates to true, I execute the code in the curly brace. If not, I do a conditional branch and skip over that. Okay, so let's add another feature to this here. We can make this a bit more general. And I'm going super slow here because this may be the first time some of you have seen this. Those of you that took CS160, you learned, if else's and if else ifs and so on. And so this is just maybe a review of the concepts in the nomenclature of C++, and it is different. So it's still worth going through, right? We can make this a bit more general by creating a branch that executes if the condition is true, and a different branch that executes if the condition is false. So let's try that. And so what I'm going to do here is I'm going to just copy that code here. Okay, so let's try that. So now if I enter 11, I get line 44 prints, but line 46 does not. And if I enter 9, I get 46 printed, but not 44. And just to make this super clear, I'm going to do 10. And so x is greater than 10. 10 is not greater than 10, right? So that will bounce down to the else statement. If you wanted to check to see if x was 10 or higher, you would use a different syntax here. Okay, and I'll show that here shortly, right? And since we're dealing with integers, right, 10 is not greater than itself. You have to go to 11 to get to be greater than 10. Okay, and so never will both line 44 and 46 execute, never, right? There's just the way that the language is built, you will only get 44 or 46. Period. Okay, and so the most common or initial way you're going to use this type of conditioning is to do input validation, right? And we talked a little bit about input validation um, in the last video here. So if I say enter a positive integer, I would change my condition to be if x is greater than 0. Let's try that. Extra double quote there. And what am I missing? I'm missing my redirects. There's a comment in, I think it's in the module, right? Yeah, it's actually right here. It says avoid copying and pasting code, right? And it says it'll force you to look at the code and make the deep connections needed to understand the concepts. That's true. But what it also does is it helps you with your muscle memory. And if you find that when you're typing the code and you're forgetting this over and over and over, if you're just copying code, you're never going to get better at it, right? And so you see me, and I don't develop in C++ every day right now, but there's been times where I do. And when I'm developing for days in a row, I won't make these mistakes, right? But when I'm doing it once in a while, you'll see me make the same mistakes that you're probably making. And so the practice of typing in, I have the code on a screen to my side here. I have the code because I've tried it already, right? And I could just copy it in. Makes the video less boring, I think. But also, I think it helps with that muscle memory. All right, so I enter 10 and I get a good job. Now if I enter 0, it tells me no, you didn't follow the instructions. If I enter a negative number, same thing. So here's an example of basic input validation. And this is only partially useful at this point, right? Because we're going to learn soon how to basically say, hey, you didn't follow the instructions, please try again. Oh, you didn't follow the instructions, please try again, right? In this case, the code, when we get to line 44 here, x is greater than 0 or it's not, but we haven't done anything to it, right? So if I'm counting on the value being positive here, then all I did was tell the user they entered a wrong number, right? So that's step 1 in this input validation. Okay, now what if we wanted 3 different conditions? Okay, so I want to respond to a positive integer, a negative integer, or 0. So what I can do here is I can say if x is greater than 0, you entered a positive number. Else, I can now say if x is less than 0, you entered a negative number. Else, you entered 0. Some of you that have done this before are already ready to say, wait, this is wrong, and we'll get to that, okay? Let's make sure this works first of all. Let's clear that. Let's try all three options here. Enter. Are we going? We're not going. Stop. Try that again. There we go. I don't know what happened there. Minus 20. You entered a negative number. 1. You entered a positive number. 0. You entered 0. Program works. Okay? And so there's a couple things here that I want to point out here. Right? So let's go through this one more time. Our first condition. If x is greater than 0, you entered a positive number. If not, then I create a new condition statement, which are basically this guy. I first check to see if it's less than 0, negative number, else I enter 0. Okay, now this is missing, no, it's not missing anything. I want to point out here that if you look at this code carefully, you see that this is what's called a nested conditional. If you look at the 3 cout statements, these 2 cout statements are indented one tab stop further to the right because there's this extra conditional statement. This is allowed. This is totally allowed. Okay, but from a structure perspective, it's not as clean as this. Okay, let's try this. I don't know why Replit is like, seems to be on weekend time right now. Okay, so all 3 cases work, right? And so if you look at this, I should have kept both. This is cleaner, right? In fact, I can just paste in. I got it, right? Okay, here's our two versions, right? The top one is 1, 2, 3, 4, 5, 6, 7 lines of code versus 1, 2, 3, 4, 5, 6, 7, 8 lines of code. No, 9 lines of code, sorry if I count that last brace. Okay, and the same number of condition statements. So it's not like super efficient compared to the other, but if you look at this is a lot cleaner. And I've seen some code that people have written where they're like checking 8 different things and they use a mix and it is like a mess. So I want to point this out so you see this, and so that as you're developing your stuff, you can keep it in mind, and you may find a point where when you switch it from one to the other, it'll be a lot cleaner. Okay, the key thing here is this is more uniform, it's more structured. And if it's structured and uniform, it's easier to maintain, it's easier to debug, and it's easier to find a bug when you have one, right? All right. Let's do another one. Now I'm introducing a new operator here. Actually, I don't want that. I don't want to do that yet. Okay. Actually, all right. I should have just kept my code. I'm typing in the exact same thing I had before. I'm just going to keep it. Okay, that's what I had before, right? I could instead do this. Yeah, let's try this. This is what I'm trying to point out here. So now if I run this again, oh, sorry. Okay, so 0 still works. So instead of just saying else 0 at the end, I'm actually doing an else if, and I'm checking to see if the value is 0. We're going to talk about this double equal thing in a minute, but this is basically checking to see if x is equal to 0, not assigning x to 0. Okay, so now if I have an else clause, there is no input that we can enter in this code that will get line 46 to print, right? Because our value will first check to see a negative number. If not, we go to line 41. We check for a positive number. When we get to line 43, the only number left is 0. Then we check for 0. So when we get to line 45, there's no number in the set of whole numbers or integers where line 46 will print. Okay, and this is good because you could put this like you could put an error statement here. And so if your code is thousands and thousands of lines of code and you get error, I shouldn't be here, there's a hint there and you can go back there because your conditional will never be this simple, right? You might be checking the results of tax calculations and you think that you've covered all the cases, but you actually haven't. And so like here's an example where I can just change this. And if I meant to say that I wanted x to be equal to or greater than 1 versus just 1, I get my error message here. Okay, so I would recommend that you write your conditions in a way so that you always cover every possible condition. And if you end up without an else, like if you don't have an else with nothing, then add it with an error statement. And I guarantee it'll save your butt at least once. All right, let's talk about the double equal thing here and the double equal thing versus a single equal thing. Now so let's just go. So a very common mistake that people make. Actually, I created this bug recently in a prototype of something I was doing, and it was like, yep, it still happens. Okay, so Replit doesn't like it. Okay, so I want to say if x is equal to 0, print 0, right? Replit complains. So let's switch over to Visual Studio. And so Replit helps us in this case. So let's run Visual Studio here. Okay, so now my program pops out in the console window, right? So I'm going to enter an integer value, and it says it's not 0. Okay, seems to work, right? Let's try it again. Enter 0. Oh, it says 0 is not 0. Well, that's wrong, right? Okay, so let's see what happened. If I print out x at the end of my program, let's see what happens. Okay, x is 0, but it's telling me not 0. there's still a clue here that I'm missing. Now let's try a different value. I enter 10. It says it's not 0, but it's now x is equal to 0. Okay, so there's your clue. What happened here is I assigned x to the value 0 in this statement. I didn't compare it. And so this condition does not work. And so this is a common bug that I see and I've implemented here, where you need to do a double equal. That's a comparison. Okay, let me do one more example here. I'm showing you another operator here, introducing another operator. This one right here is not equal. So this should work. Oh, what did I do wrong? Oh, I'm missing my end brace. Yeah, it says on line 43. So this blank area was expecting a curly brace, right? And it's saying that it didn't find a brace to match this guy, but it's really a brace to match this guy. Replit helps you here a little bit too. So you notice that when I click on braces, it highlights its other half, which is helpful. Okay, so since A and B are different, now I could have used an else here as well, right? So again, I'm doing two separate conditions here. And in this case, depending on the conditions, unless they're mutually exclusive intentionally, both of them might evaluate to true, right? And so, but the point of showing this here is, again, the double equal. If I take this code, again, and I put it into Visual Studio, or VS Code, same problem in VS Code, and I think the same problem will happen if you're using Linux as well. Let's see what happens here if I have just the equal sign. I get the right message, right? But what happens here is if I go here and let's just do this. I'm going to set a breakpoint. We'll just do it this way. Okay. If I go here, you can see A is equal to 6 and B is equal to 6. So line 12, instead of comparing that A and B are the same, it actually assigned A to 6 and busted my code. Okay. This is using a breakpoint in Visual Studio. I think I posted a video on how to do this last week, right? So it's a useful way to debug here. I can click stop and then exit that. Okay. Another important distinction about how we code these things. Okay. I've done something a little different here, and I'm going to circle back here in a second. Let's run this and see what happens. Okay, so A is not equal to B, so this evaluates to true, and you can see I have my statements that are printed here, right? Okay, Now if I change this, actually I think I can keep all, this is one where I can have all the examples at the same time. When I hit return, take note of where the cursor is. Okay, I'm pausing here for a second. You see where the cursor is? Let me demonstrate it again. I hit enter. See where the cursor is? Okay, so then I just do that instead. So I type my command and I indent it. Okay, A and B are not the same. So this guy did not print. And you might have expected this also to not print, but it did. Okay, if this was in Python, line 46 would not print, right? Put my colon there and change that to print and so on, it would not work. Okay, so what's going on here? These if statements are missing their curly braces. Okay, so let's do this. And yes, I meant to type 4. I'm going to take these two lines. Okay, so why did it not work? Why did that not work? So this line printed, example 2, example 4, neither of these, no, it did work, sorry. Neither of these printed because A is equal to B. So if I change that to that, now both lines are printed. Okay, so now let's do one more. And now example 3, I'll get my condition where the inside doesn't get printed because this evaluates to false, but this will automatically and always be included. All right, this message here and this example here that we've just done, and I see production software engineers not do this, and it's like rule number 1 that I put in place when I'm doing development is use your curly braces for your if statements, even if you only have one line. C++ lets you do a conditional with only one line and not need the curly braces. That's what's happening right here, and that's why this works. The language lets you do it. In 4.9, here's the missing braces. So this is this is not the exact example, obviously, but this is the point that I'm trying to run through. So I would like you to, here's some like more substance examples where the calculation ends up being wrong. Right? So let's look at one of these real quick here. Let's look at this guy. So number of items is 0, bonus value is 5. If the bonus value is greater than 10, then I change my bonus value to 4. That's what this is doing. And I set my number items to equal to 4. So if bonus value is greater than 10, right? If I am looking at this without recognizing I'm missing my braces, I think both of these get executed, or in this case don't, because bonus value is not greater than 10. And so number of items would be 4 plus 1. I would put 5 here, and that's wrong. Okay, so the real answer to this is 1. Yes, it is, right? Number of items is 0. Number of items gets equal to bonus value, but bonus value doesn't get decremented, right? So this doesn't happen. So bonus value is still 5. And by the way, if you had this printed, right, you'd write these numbers, you do this hand tracing, right? So you kind of have to do this mentally. Bonus value is not greater than 10. So the line that's highlighted doesn't get executed. So number of items gets assigned to 5, and then we add 1 to it. That should be our correct answer. Okay. So go through these, go through all of them, right? Because it just helps again with that intimacy, or that the commonality of learning how some of the subtleties about this here. Okay. All right. I wanted to do this at the start here. I skipped something here. So let's do another example. Now let's the total hours worked is greater than 40, and take what is going on? Excess hours and count them as time and a half for overtime. The common method of how hourly pay might just get generated here. Okay. So I'm going to declare int hours worked int overtime equal to 0. Note I did not initialize hours worked because I'm going to assign it in this statement before I use it, right? There's no downside to assigning it, but in fact I generally recommend that you assign it, right? So then we're going to say if hours worked is greater than 40, I could put a statement in here to help me. Need to calculate overtime. And this could just be during development. Overtime is equal to hours worked minus 40. And then I'm going to change hours worked to 40. Okay, so what I've done here is if I entered 50 hours, I calculated my overtime at 10, and then I just set hours worked to 40, right? And so now I can say hours at regular pay overtime at time and a half Okay, so if I enter 40 hours, I get 40 hours regular pay and no overtime. If I enter 41 hours, I get 40 hours of pay and 1 hour at overtime. If I enter 39 hours, I get hours at regular pay, overtime of 0. When you test your code, I don't know if I've mentioned this before, you're not going to test all infinite numbers of values, obviously. You're not going to test 37, 38, 36, 35 hours, right? You got to pick the test cases that make sense, right? And so you saw what I did is I did the test cases that were near the conditional, 39, 40, and 41, right? You want to test those cases. You also want to test weird cases, right? Like 0, or if you have a maximum value, right? So you don't need millions of test cases, right? But if you only test one test case, this is not a law of physics, but if you only test one case, you're going to have a bug in the other case, right? That's what experience says, right? And bugs go to where you don't test. So when you have a conditional like this conditional, test 39, 40, and 41, right? And if it's a floating point value or a double, then you want to check like 39.9, 40 even, 40.0, 40.1, and so on, right? All right, let's check to see if a comparison between data types work. I think most of us would expect this to work, right? And it does. The value of A and B are the same, even though they're not stored the same inside the system, right? Because the double is actually 10.000 and so on, right? Okay. Now, but if you're doing some very, very precise mathematics, let's see, let's just put question marks there. Let's see if it works, right? I would expect it not to work, right? And I forgot my semicolon. Because 10 and 10.000000001 are not the same, right? So I'll be clear here. I expect this not to print. And it doesn't. Okay, but line 22 is deceiving, all right? And that's because I'm only setting the precision of what I print 10 to 5. So you got to be careful here if you're comparing floating point numbers. You have display distinctions versus storage distinctions. And there are, of course, cases where you think the number is something and it's not because of the inaccuracy that's native in floating point numbers from time to time. Okay, let's do one more. We'll do two more actually, I think. Let's do a character of 5. Okay, are A and C the same? At first glance, you might say so. Yeah, they are, 5 and 5. I think it ran. We'll put another statement here to make it obvious. What did I do? And L. See, my muscle memory still fails. All right. Nope. Okay, so this evaluation, this conditional evaluated to false. Okay, remember that a character is represented as its ASCII value in binary. So whatever that number was, 87, 89, whatever that number was, is not equal to 5, right? And so this comparison will not work in this case. Okay, let's do a string. Okay, so this comparison evaluated false because there's an extra space right there. Okay, so these two strings are not the same, even though when you print them out, they may look the same. Okay, if we remove that space and change our code, it worked. All right. I didn't do a very good job. Actually, I didn't do it at all, right? I didn't kind of walk through the book as we went through this. I think it's a good time for me to kind of bounce back here, and we'll do a little bit of this. Go through this stuff one at a time, because you'll find that it helps set that knowledge here, right? Here's an example of calculating an absolute value. And here we'll show, let's look at the flow chart here. Okay, so we do an input statement to get the value. We're going to check a conditional. If it's less than 0, we're computing the actual value, right? So if it's we're going to check to see if that number is less than 0. If it is, then per the rule of an absolute value, we have to change it to its positive value of itself. So if that conditional evaluates true, we go here and we set val equal to negative val. And so that what that does is it changes your negative 99 into positive 99. And then that comes down here and it will output that value. If the value less than 0 evaluates to false, we just come down. This line should just go straight down. There's some goofy graphics right here. Okay, and so this is an example of using the in your flow charting. A conditional is most often designated as a diamond like this, where you have your true and your false coming either bottom, left, right, however you want to do it. Okay, so if the input is -6, does the branch execute? Yes, it does, right? Because if the value is there, right? If the input is 0, does the branch execute? The answer is no, because we're only checking to see if it's less than 0. Okay, so more of these similar examples with if-elses, right? So this is an example here where if x is greater than y is evaluated, if it's true, you do something. If it's false, you do something. Okay? So lots of examples. And if this stuff is confusing, go through it one at a time. Okay, here's the double equal thing. We talked about that in detail, so we don't need to go through this. Lots of examples. I was like amazed how many examples were here the first time I saw this. I did want to go through this example next, because I think this is a good way to describe how to do these more complicated conditionals. Okay, so we are going to create some code. This is playing with 4.3.1. Is that right? Double check that. 4.3.1. Okay, where you know, you're signing your kids up for soccer and you have to enter the kid's age, and the program's going to automatically assign your kids to the right teams, right? So int age. All right, so we're going to do this kind of in an ad hoc way. We're going to say if the age is equal to or greater than 8 and the age is less than 10, we're going to assign you to the age group 8 league. Okay, so I did something new here. This is new, right? This is a Boolean operator that operates on multiple expressions. So if age greater than to equal 8 is true and age is less than 10 is true, this line 24 will execute. I wish it didn't put these parentheses because I just want to keep typing. Actually, I think it works actually. play on U12, U10. Okay, similar comparison. If once you hit 12, you're aged out of this league and you can't play. And if you're younger than 8, not yet eligible. All right. Okay, so this should work. Let's try this. Again, we're going to try the various different examples, or the various different numbers that bound. So let's try 8. Let's try 8 first. 8. So 8 plays on 8. Let's try 9, plays on 8. Let's try 10, plays on 10. Let's try 11, play on 10, 12, aged out, and 7, not yet eligible. So I tried all my numbers that I cared about. I guess I could try 13 too. That's also aged out. Okay. Code's perfectly okay, right? It runs correct. You can look at it and it makes sense. But what I want to show here is there's a couple problems with this code. And the best way to show this is to count the number of comparisons compared to a better way to do this. Actually, I'm missing an age. We have 10 to 12. Oh, I have my code wrong. I have my code. It doesn't match. I think play on U8 is under 8. Okay. Let's add this. The league is based on the max age. So there we go. Okay, and that should be less than 6. All right, so here's our version 1, which works, but I don't like it. Okay, so I'm gonna suggest a new version. Okay, why is my braces not working here? Let's try this. If we look at this code briefly, we start with the lowest age. So we say if age is less than 6, it's trying to help me, but it drives me nuts adding these braces. Now you can see what I'm doing here. If your structure is uniform, you can copy and paste lines, and for the most part, get what you want. All right, so when I run this, I have 2 blocks of code. I should get the same message twice if my 2 blocks of code always work, right? And this is another debugging technique. If you're trying to develop something and you've changed it, and how many extra wrong braces do I need here? Okay, so if I enter 5, in both cases I'm not eligible. If I enter 6, I play on U8, 7, U8, 8, U10, 9 should be U10, 10 should be U12, 11 is U12, 12 should be aged out, and 13 is aged out. So my messages all worked. Let's look at the two versions here and see what we can tell that's different about them. If we look at the version 2, let's look at line 48. Line 48's condition is players that are ages 8, 9 up to 10. But but this condition is any age less than 10. So if I had a 5-year-old, this condition by itself would evaluate to true. But if I had a 5, this would have evaluated ahead of time, and this would have printed, and then I would have skipped the rest of these. Okay, what I'm doing here is I'm creating each condition independently of each other. And so I have 1, 2, 3, 4, 5, 6, 7, 8 expressions versus 1, 2, 3, 4. My code is half the size. It is much more structured, and it's going to be less error prone, because here is where you're contending with, like, what if you're right on the border? If you forget and if you do this, and if you do this, and you forget that greater than equal on line 29, when I run this at age 8, let's see what will happen. This top one fails, right? I get no message here. Conversely, also, if I have the less than equal there, and I enter 8, I get this bug. I see this in CS160, assignments 2 and 3, I see it all the time. Some of you might have done that on a code that I graded, right? And I see it in CS161 as well. So this is why I'm spending an extra few minutes on this version here to talk about this. The book describes this, right? And I think the book does a good job of, elegantly detect ranges, right? That's what we're trying to demonstrate here. Okay, when an expression is checked, one knows that all the previous expressions were false. Thus, it gets rid of the need to explicitly check one half of the range, right? Okay, so here's an example that I really suggest you go through, and another example that you should go through, because if this seems a little confusing to you, that's okay, but this section will let you play with it and get more comfortable with it. Okay, and so I want to show you all the operations here instead of typing them. They're here. That's where they're right here. Okay, so these are called relational operations. I don't think I used the word relational yet, right? These are numerical comparisons. Okay, and so the less than sign, we know what that means. A less than B means that A is less than B, right? We can put an equal sign with it, all right? And if we do, that means that it's A less than B or A is equal to B, one or the other, okay? A common bug that you will probably make is you'll switch the order of these two characters and you'll do equal to or less than. Because when we're talking about this in your math teachers, and I do this too, I don't always say greater than or equal. I might say equal or greater than, right? Word-wise, you might switch them, but the programming language doesn't let you do that, and you will get an error. In fact, let's try to demonstrate that actually. I'm changing the rules of the program here a little bit, so I change this to less than and equal, right? So now 6 is not eligible. But if instead I do that, let's see what happens. You get a syntax error. Okay, some programming languages let you do it, and it's allowed both directions. But C++ does not, because there's other ways putting the equal sign first does for other operations. Okay, so you can test your work here, kind of start to combine all that together. Yeah, this is, you finish this section with an example similar to the soccer. I mean, it's the same thing, right? Fish tank capacity, right? Okay. 4, 5, logical operators. All right. We talked about relational operators, okay? Logical operators are comparing Boolean values. Okay, remember Boolean, well, maybe not remember. We may not have explicitly said what a Boolean is. A Boolean data type is a piece of data that can be true or false. And in CS160, we talk about that, right? True or false, 1 or 0, yes or no, off or on, right or left, however you want to define it as, right? But most commonly, true means 1 and false means 0 as a single bit, right? And so a Boolean data type is a single bit. It'll be a 1 or a 0, and most programming languages associate the symbolic true with 1, and the symbolic false with 0. These things right here are called truth tables. And there's three logical operators we're talking about in this section. And, or, not. Okay, so if we look at the truth table for and, if I have two Boolean variables, each could be true or false, I only have 4 possible combinations for those. A is false, B is false, A is false, B is true, A is true, B is false, and A is true and B is true. And for all 4 of those cases, I can write them out. And A and B will evaluate to false unless they're both true. In other words, both have to be true for the output to be true. Okay, the logical OR is the same kind of thing, right? But A or B is going to evaluate if A is true or B is true. And this is what's called an inclusive OR, because if A is true and B is true, A or B is also true. So think of the logical OR as A and or B are true. It's not exclusive. And so if you want to test for an exclusive OR, that's different, right? An example of an exclusive OR is it's either a positive number or a negative number. It can't be both. Okay, and then finally the not is simply if A is false, then not A is true, and if A is true, then not A is false. And this is actually surprisingly useful. If you look at the circuitry inside a microprocessor, right? If we were to open up the circuitry of a microprocessor, an Intel i9 or whatever it might be, and we were to zoom in billions and billions of scales and we were to point at little circuitry, what you'd learn here is that all circuitry is basically made up of things that do these 3 operations. And the number of these on the chip is amazingly high. This is how important it is. So actually the importance of all 3. Okay. So here's the description. This is the description of what I just talked to, right? And so we can go through some of these examples. If X is 7 and Y is 9, let's do number 5 here. X greater than 10, that evaluates to false. Y greater than 20 also evaluates to false. So false ORed with false is false. So walk through these, right? This is what you need to do. Okay, you can use, here's another example. If we want to detect to see if a number is between 1 and 99, let's look at different, we got 3 different ways to do it here, right? 0, oops, well, I gave you the answer. 0 less than x, okay, so that means x is greater than 0. That's okay to have that the other way, right? And x is greater than 100. That doesn't work because x needs to be less than 100. Okay, so that tells us that this guy is right. But why isn't this right? Let's look at that. I'm going a little out of order in my code, by the way, when you see the final file. Let's try this. See. All right, let's see if that works. Like intuitively, you think that would work, right? Replit doesn't like it. And there's a kind of complicated error message that it gives. So now let's double check and see what happens in Visual Studio with this same code. All right. So let's try it. Okay, so it seemed to work for a value 55. Let's try it for 101. It didn't work for a value 101. Okay, so again, here's an example. Replit helps you more than Visual Studio does. Visual Studio, it was there. I saw it. There was a warning message. I did see it. There was a message there. Okay, warning. It was there. I don't remember what window that is to bring that back. Why is it not? All right, I'm missing something here. I don't see, it's not showing me the error after the program starts to run. The message was an unsafe use of a Boolean operation or something kind of like that. Okay, see, it didn't work here as well. Okay, so I'm dwelling on this. This doesn't work. Okay, this doesn't work. And it's not allowed in most programming languages because it's not doing an illogical operation, right? Or sorry, it's not using a logical operator. It's using 2 relationals together, and it's not combining those in a way to do a logical comparison. It's a common mistake I see. Some programming languages try to be tricky and let you kind of do it when you can't do it. So that does not work. All right, I want to go back to the nested operations again. Because if you remember earlier, I showed you that example where I had an if statement inside another if statement. Here's a case where you want to do it. What if I want to make a decision and then based on that decision, I want to make another decision? So I'm going to write a app that's going to help me, give me some advice based on what workout I'm going to do here for my my triathlon training. And to keep this easy, I'm going to skip this. I'm going to skip the bike part. I'll have to add that later, right? Otherwise, my program gets too big. let's stop for a moment here. Okay, so I have a question that I ask. And then, based on the answer to that question, I ask a question specific to that, right? So in this case, I'm only going to ask pool versus lake if I enter swimming. If I enter running, I'm not going to ask about pool or lake. Okay, so then I could say, here in Seattle, in my case, in Portland, some of your cases, if you're going into the lake, you probably want your wetsuit, right? And okay, so there, this code, or I should say this code, is nested inside here. Okay, so that guy matches with that. So else, Replit is a little bit, sometimes it doesn't want to match your braces, so you kind of have to keep track of that. So now I'm going to do my same thing for the running exercise, and I'm going to double check and make sure my indentations are correct, because when I hit return, it seems to want to bump me back. So let's see what happens. Here in the middle of April, it's sunny here in Seattle today, so we'll do this. Else. That's interesting. I have some funny indentation problem. Let's see if we can figure out what this is. That guy matches. That guy matches the else, but it's not indented. Let's see what happens. This is where I need the students interactively to like tell me where my mistake is, because I know the code works because I've tried it, but I gotta see where my error is. So let's see. We're looking for missing semicolons. We're looking for busted like this. This is not matching. See that? This break. So this like that connects to that. That connects to that. That connects to that. This should connect to that. And the question is, why is it not? We won't spend forever on this. If I can't figure it out, we'll reconstruct. I'm not seeing what the problem is. Oh, I see. All right. I haven't done this before. I have an if, else, else, right? And so instead, this should be else if event equals 2. Yeah, you can't do an if else else. That's what it was complaining about that, right? It was basically this else close this, but this stuff here, it didn't know what to do about that. So we need to say else if event equals 2 here. And we got to do the same thing here. Well, I can leave this as is, right? I can, because basically I'm assuming I'm not doing any error validation here. So now let's try to run that. Okay, you either got a headache during that conversation or you were able to follow, right? So I enter 1 for swimming, I enter 2 for lake, and it gives me that advice, right? I enter 1 for swimming and 1 for pool. If I enter 1 for swimming and 3, it tells me, nope, that doesn't work. If I enter 2 for running and 1 for road, it tells me that. 2 and 2, it tells me that. But I don't have the validation here, right? Because I just have an else statement here. Okay. In the code that I'm looking over to the right here, in the code that you'll see me post, it does have that, right? Okay, so this again is called a nested if. All right, thanks for bearing with me. I have one more example to do. We're gonna talk a little bit more about logicals, and then we're gonna finish up here. Just because C++ wants to confuse you more, you could use, like I've been doing, the code. Actually, it doesn't show it anywhere in here, so we're gonna demonstrate it. Actually, we could do this way. I haven't really demonstrated this very much, right? Where you can actually do this. This gets tricky because the user needs to know what you're trying to do here, right? So, if A is less than 10 and B is less than 10, okay, let's try this. Okay, that works. In the book, you notice here that we're using and, or, and not in capital letters here. These are not lines of code. We're just talking about the operators. Okay? And so if I change that, I should get an error. And I do, right? It doesn't like that. It is common in C and C++ that instead of typing the word and, you use a double ampersand. That's the ampersand symbol there. That's your shifted 7 on your keyboard. So if I try that, both lines, this is identical. C++ is an obfuscated language. Lots of symbols, lots of shortcuts. And I personally like to use the word, especially because it's only 3 characters. It's not like it's saving me a lot of space. Okay, but let's do this. Now let's change this. This symbol, so the OR operation can be also represented, and it's like doesn't save you any space or time, right? Let's try that. 4 and 22. Okay. So the OR statement works. This symbol here, the vertical bar, is your shifted backslash on most keyboards. It's the shifted key I'm looking at my keyboard right now, that's under the backspace and above the enter key, right? It's a vertical bar. Those of you with Linux knowledge call that thing the pipe symbol, right? So, and so here's your logical and your logical or, and then your logical not is an exclamation point. Let's demonstrate that real quick. If it's a little convoluted, right? Okay, A is not less than 10. So if I enter 10, I should get that message. Oh, I need my other number. Yeah, A is not less than 10. And I can use my symbol instead. And I should get the same. I should get the same output. Okay. So the book doesn't show the use of the words and, or, and not. They're using the logical symbols here. Okay. Notice that there's this double exclamation mark. That guy goes there, right? That's not that's not a value here. So you got your and, your or, and your not. And then there's some examples for you to run through and do this. If you follow the example we just did, you should be able to walk through this stuff. Lots of good examples here. All right. I think we are done. There's some extra stuff in here for you to go through and some more examples. Section 4.8 shows you the some good examples with your pseudocode and your flowchart, if that's something that you're struggling with. Otherwise, as usual, post questions on the discussion board or email me, and we'll get some of that stuff answered if you're running into any trouble. Thanks for sticking with me. We'll talk soon.